continue. Okay, so we have this. We measure reflectance in different wavelengths. This is related with the phenology, the type of crop, and variety as well, with the weather, close correlation with yields. How do we apply? And we have a number of service satellite providers. So how do we apply all this? Okay, Henny, thank you. It's joining from Marble Hall, Limpopo. Leon is joining from Pumalanga. Jax from PART. Okay, thank you. And Francis, as I said, from Limpopo. Sample applications. This is where the interesting part comes, or the more interesting. Now, before we go into applications, keep in mind that different resolutions, those spatial resolutions, have different applications. So mid-resolution, like 22 meter, this is a sugarcane farm in Venezuela, will have a certain degree of resolution, a certain level of resolution, and 5 meter will have, of course, much higher resolution. You can see more things. This is a sugarcane farm in KwaZulu-Natal, and you can see 30 meter resolution on the left and 2 meter resolution on the right, where you can start seeing the plant population or some other issues in much more detail. But still, with a 30 meter resolution, you have a good level of detail to appreciate some of the differences within the field. So you have to keep in mind, low meter resolution, you can do certain things like scout determine issues that are affecting the health of the plant. Some things may be cannot be changed for the current year, but can help you make decisions for the next one. The correlation to a yield map is a very useful feature. At higher resolution, you can go into equipment problems, population issues, maybe insect disease pressure, nutrient deficiencies. So you'll have different levels of use for different solutions. Now, something we emphasize from GeoAgroAfrica is that imagery is an indication, but the experience of the agronomist, the field practitioner, the field manager, it's key. You need to go to the field and evaluate why we have the differences. That can have many forms. It can have many types of reasons and also many different types of indices. But the main concept is that imagery is to support for the field visit and the decision. So this is an example. This is a farm in Congo. We see a field with different issues. This is a 6 meter resolution from April 2015. And when they go to the field, they can evaluate why it's showing in the lower ranges of NDVI. So here we can see poor condition, P deficiency. We see a form with different attributes, the growth stage, average plants per 10 meters. And so one of the important aspects is that you define what information you want to capture in the field in order to correlate with the imagery and in order to make useful conclusions. In this case, it was evaluating plant populations. Again, detecting issues. This is a sugarcane farm in Venezuela with 5 meter. So here we can see very clearly the drainage issues. This can guide the field decision. This can help take decisions for the next season. This is a farm in South Africa, irrigated pivots. And we can see there that there are some irrigation nozzle issues that are causing different growth stages or growth status in the farm. And again, this is with 30 meter resolution, so you see that for certain decisions, 30 meter is very practical, quick, effective, and affordable. This is in Brazil. They are relating very clearly the different epocas or the different varieties that they have in a soybean field. As it's evolving, they can see the erosion due to drainage very clearly. They can see the flooding in some areas. So when they go to the field, so that helps them make decisions for the next season if they're going to grow. And depending on if the season is going to be dry or wet, make decisions on and make the yield per hectare higher and more profitable. And something very interesting that you have always local aspects. So you have the capybara, which is a very cute animal in Brazil. You see him there making damage. It's very cute, but it's so you have two choices. You can be environmental and friendly and get the capybaras out of there, or you can be more reasonable and leave the guys there, but not grow crops there. So, but this is really objective measure that how your field is performing and what is going on in the field. Okay, I'll show a couple of more examples, and then I'll switch the screen to Francis, which is going to be more interesting than me because he's making decisions all the time. I'm just a guy in the back office. But just what we're trying to get across here is that it's not something that will come from the service provider. It will come from you, determining what is important for you and what methods you're going to use, and then use imagery depending on those goals and on those methods that you're going to use. This is an interesting example from the Iowa Soybeans Association, very strong association in Iowa. If you ever go to Iowa, we'll see a lot of soybean, corn, and pigs. It's a state that's dedicated to that. So it's called the Soybean Association, but actually I think they have more corn than soybean. So they wanted to determine how much they were optimizing the use of nitrogen, and they had a method which it's called cornstalk test. It's a tool for evaluating nitrogen management. So it's based on the fact that corn plants suffering from inadequate nitrogen remove nitrogen from the lower corn stacks, and if you have excess nitrogen, you will have more accumulated nitrate. So basically what they do is they have standardized tests from a certain distance from the field. They take a corn stalk in 8 inches in length, and then they analyze it and determine the nitrogen content. But this is much more efficient if you use imagery to support it. So they're going to see if there's correlation between the low or higher biomass with the cornstalk test. So then they have a low, optimal, and excess map of nitrogen use. We'll see nitrogen is one of the good candidates for application of imagery, and I think from the economic point of view, what we're seeing is well, fertilizer optimization, nitrogen management through the season, and we're seeing more and more variable rate corn seeding as I would say one of the three very profitable applications of all these technologies. Okay, this is an interesting case in rice in Argentina. In this case, what happened is that they made a mistake in applying a chemical product. They didn't wash the tank properly. I'm sure we have that we have heard of that in different countries. So, but what this actually does, imagery can help evaluate the damage. So here we see pre-damage monitoring. So remember, we're getting Landsat images every 16 days, 30-meter resolution. That's where we are. So we see what's this crop status November 8th, November 17th. And then November 24th, we start to see an anomaly. Again, seeing between quotes, because we can also do some automated operations in order to detect those anomalies automatically. So we start to see between quotes anomalies, and we see that there's a line there that's not growing as expected according to how it was evolving before. So they evaluated that there was an application incident. There was a mistaken chemical application during the first week of November that starts to show in the third week of November. And this is GeoAgro Africa works hand in hand with ag service organizations. So in this case, the Stoller, it's a company, it's a multinational that sells high-value fertilizer, and they also sell stress mitigation products. So they were providing the service to this farmer who detected this stress, and there was an opportunity to mitigate that damage. So on December 5th, they applied a product called BioForge, and they were able to monitor how that product was helping the crop to overcome that stress. So we have this image from 19 December. We see that same area, the stress disappearing, and by January 4th, it's completely gone. Again, it's a rice field, and this was a very useful example to see how to detect stress, how to make a timely decision, apply the right product, and then how to monitor results. Okay, another application is yield estimation. Wheat, corn, sunflowers are crops that have a very close correlation in yields. Rice. So the basic concept is that you have the NDVI on one hand. You take measurements the first 1 or 2 years because you need to find that correlation. Once that correlation is established, then you can do this process for the same region, for the same type of crop, without going so much to the field, just to do a field check maybe. So the basic concept is that in different locations, according to a protocol, they're going to take some samples related with yield measurement. So that means number of spikes and amount of grain. And based on that, and based on the seed weights, we can correlate those parameters with actual estimated yields. In this case, it was 6.75. Report from the field. We didn't have a yield monitor in this case. We had reports that it was between 6 and 7. So we're happy with the results. Usually between 5 and 10%, it's the range of accuracy for this type of measurements, provided that there are no extreme events. The disadvantage is a lot of field work the first 1 or 2 years, and the advantage is that then you have a reliable measurement for the remaining years.